Hello all, welcome back to Electronics. This video is about the Zener Diode and tunnel diode along with its characteristics. Now let's get into the video. Zener Diode and tunnel diode. First let's discuss about Zener Diode. A basic semiconductor diode can operate in forward bias but it cannot conduct during reverse bias as we discussed in the PN junction diode. So Zener diode is something that can conduct in reverse bias. This diode can conduct in forward bias just like a normal diode, and the junction for the Zener diode will be heavily doped. Because of this reason, it can work as normally as a basic junction in forwarding bias and can tolerate the reverse currents during reverse bias. The main purpose of it is to use in stabilizers. This is the symbol of the Zener diode. Hence, a diode in which the flow of current is from anode to cathode and cathode to anode, defining that it has the capacity of conducting in both forward and reverse biases, are referred to as a Zener diode. It can be simply said as a specially designed, highly doped PN junction diode. Now let's discuss about the working of Zener diode. Before that, we should see the working of PN junction diode first. Usually, in a basic PN junction diode, during its reverse bias, there is no chance of conduction because the depletion layer width is comparatively high, as we can see here. As the applied reverse voltage tends to increase, that result in increment of the width of the depletion region. But there exist some minority carriers which gain some energy because of the increment of reverse voltage. Due to the gain in kinetic energy of the minority carriers, these free electrons in movement collide with the stationary ions. This results in the formation of more free electrons after collision. Further, these again collide with remaining stationary ions, and this process continues, which is referred to as carrier multiplication. Because of carrier multiplication, a huge multiple of free electrons are created and the complete region of the diode becomes conductive, resulting in breakdown known as avalanche breakdown. Generally, this does not happen in the case of Zener diode. In Zener diode, the junction is doped with the highest concentration. Because of this reason, when the reverse voltage has applied, the width of the depletion region tends to minimize. As there exists the minimum concentration, that is the maximum concentration of the impure atoms in it, it creates the maximum number of ions in it. As soon as the diode exceeds the threshold value, the electrons that are in the covalent bands tends to come out in the depletion region so that it can make depletion region conductive. Hence, this type of breakdown is referred to as Zener breakdown, and the occurrence of this breakdown will be at certain voltage termed as Zener voltage. This value of the Zener voltage is properly adjusted at the time of manufacturing by the proper concentration in doping. Now comes to the characteristics of Zener diode. Here, when the diode is connected in forward bias, this diode acts as a normal diode. But when the reverse bias voltage is applied, when it is greater than Zener voltage, a sharp breakdown takes place here. That is at the VZ, that is Zener voltage. It is also known as knee voltage because at this point the current increases very rapidly. Now let's see an application of Zener diode. As the principle of Zener diode is already discussed, when the reverse voltage is applied, it crosses the basic Zener voltage and then the diode starts conducting. Once the voltage limit has been crossed, there is no increment in the voltage, but after it, the current can increase. The range of breakdown, that is Zener voltage, lies in between 12 volts to 1200 volts based on its typical application. The voltage that is to be regulated is across the resistor RZ. To it, a diode is connected. Whatever the voltage has been selected to be regulated, it must not cross the limit value, that is VZ. Zener diode is connected in reverse bias, so once the Zener voltage exceeds, then the current flows through the diode. But there is a voltage drop that is unnoticeable. Hence, in this way, the voltage is limited across the load. In this way, it is used as a voltage regulator. This is considered as the basic application of Zener diode. Generally, the power dissipated is the multiplication of overall current and voltage values, as we all know that. Here, the power dissipation of Zener diode will be given as P equals to Vz into IR, where Vz stands for the Zener voltage and IR stands for the reverse current. Now, let's discuss about the tunnel diode. A tunnel diode is a heavily doped PN junction diode. This tunnel diode shows negative resistance, that is, when voltage value increases, current flow decreases. Tunnel diode works on tunnel effect. Tunnel diode shows a negative resistance in their operating range, so it can be used as amplifier, oscillators, and in any switching circuits. This is the symbol of tunnel diode, and this is the equivalent circuit of tunnel diode. Now let's discuss about the depletion layer width in tunnel diode. When mobile charge carriers, both free electrons and holes, are missing, the region in PN junction has a region called depletion region. To stop the flow of electrons from n-type semiconductor and holes from p-type semiconductor, depletion region acts as a barrier. Now, depending on the number of impurities added, width of the depletion region varies. To increase electrical conductivity of the p-type and n-type, semiconductor impurities are added. A wide and big depletion region is formed when a smaller number of impurities is added to a PN junction diode. At the same time, when a greater number of impurities is added, the depletion region narrows. The p-type and n-type semiconductors is heavily doped in a tunnel diode due to a greater number of impurities. Heavy doping results in a narrow depletion region. When compared to the normal p-n junction diode, a tunnel diode has a narrow depletion width, as you can see here. See, in PN junction diode it has a big depletion region and it has a normal depletion region in tunnel diode. Therefore, when small amount of voltage is applied, it produces enough electrical current in the tunnel diode. Now, let's see the tunneling effect. In electronics, tunneling is known as a direct flow of electrons across the small depletion region from n-side conduction band into the p-side valency band. In a PN junction diode, both positive and negative ions form the depletion layer. Due to these ions, inbuilt electrical potential or electric field is present in the depletion layer. This electric field gives an electric force to the opposite direction of externally applied voltage. As the width of the depletion layer reduces, charged carriers can easily cross the junction. That is, the charged carriers do not need any form of kinetic energy to move across the junction. Instead, carriers push through the junction. This effect is called tunneling, and hence the diode is called tunnel diode. Due to tunneling, when the value of forward voltage is low, value of forward current generated will be high. It can operate in forward bias as well as in reverse biased. Due to high doping, it can operate in reverse biased, as we discussed before. Due to the reduction in barrier potential, the value of reverse breakdown voltage also reduces, so it reaches a value of 0. Due to this, small reverse voltage leads to the diode breakdown. Hence, this creates negative resistance region. Now, let's discuss about the characteristics of tunnel diode. Due to forward biasing, because of heavy doping, conduction happens in the diode. The maximum current that a diode reaches is the IP, that is, and the voltage applied is Vp. The current value decreases when more amount of voltage is applied, that is beyond this IP. Current keeps decreasing until it reaches the minimum value. The small minimal value of current is IV, that is, it occurs at the valley point. From the graph shown here, it is seen that from point A to B, current reduces when voltage increases. That is the negative resistance region of diode. In this region, tunnel diode produces power instead of absorbing it. The applications, that is the basic applications of tunnel diode, are it can be used as a switch, amplifier and oscillator. Since it shows a fast response, it is used as high frequency component, and also tunnel diode acts as logic memory storage device. This is all about tunnel diode. If you have any queries regarding this topic, please reach us at anitronics.info@gmail.com. Thank you for watching this video.